This session today is on the value proposition of low-code development. And if I can get my slide to progress, it would be nice. There we go. Hello, my name's David Peake. I'm the Senior Principal Product Manager for Oracle Apex. I've been with Oracle a long time. I actually started with in Oracle Consulting many years ago in Australia, then I moved to New Zealand, and I've been in the US a number of years now. And I'm responsible for Apex product management together with Chaitanya, and I've been doing this since 2006. And these days I'm based in Denver, Colorado. And if you want to connect with me on Twitter, then it's ORCL_DPeak. So today I'm going to be talking first of all about the app dev conundrum and the problems facing IT when it comes to developing new applications. Then I'll be talking about the low-code development platform and what is it. And then looking at how Apex fits into that as a low-code platform, and then talking about how to actually implement that within your company. So first of all, let's look at the app dev conundrum. There's a number of priorities that IT has. First one is operations, keeping the lights on, maintaining the data centers, doing things like ETL, data recovery, backups, all that sort of thing. Another major priority for IT is enterprise apps. So those mission critical apps that are company-wide, that are required to keep the company running. Things like ERP, CRM, etc. Another major priority for IT is migrating to the cloud. So a lot of IT resources are taken up with researching the cloud, planning to move to the cloud, testing it, executing, and so on. Then another major priority is security. So making sure there's no data loss, doing things like email, encryption, and so forth. And then there's a number of other priorities, things like big data, microservices, artificial intelligence, chatbots, mobile, customer-facing apps, dashboards, and the list goes on and on. And then last on the list is departmental apps. So one of the problems that is facing the IT departments is they would love to build more apps for departments and what have you. However, they've just got so many other higher priorities that they rarely get time to really devote many resources to that. When we look at the departments within an organization, then they have differing priorities. The first one is to improve their business practices. So making sure they replace paper and antiquated processes and streamline them. Another one is to adapt to a changing landscape. So being able to change with new competitive forces or disruptors to be able to modernize the way that they go about doing their business. Yet another one for departments is increasing productivity. So with the push to maximize revenue, then the departments are always trying to do more with fewer and fewer people. So they need to be able to do things faster and more efficiently than they have in the past.
Hello.
And I've got somebody on mute. I'm just going to go very quickly in and mute all participants. And Tim, you'll be able to unmute yourself if you need to. And then the next one here is to be able to meet objectives. So being, making sure they stay within their budget while achieving their corporate goals. And then the last one on the list for departments is being able to innovate. And so that's being able to experiment with new cutting edge practices and be able to, try out new things. All of these priorities generally require applications to achieve. And so what happens is we have, generally within many organizations, we have what's called shadow IT. And the reason we have these is primarily because IT is not meeting critical departmental requirements. They're unwilling or unable to develop the apps required as quickly as the departments need them. The business users utilize whatever tools they can. So they're using things like spreadsheets or MS Access or SharePoint or whatever they can get their hands on to try and facilitate the work that they're doing, and generally not very efficiently, but it's better than nothing at all. You know, spreadsheets, don't get me wrong, are very powerful, very useful, but they're not very good for things like data sharing. So, you know, if somebody's sending out a spreadsheet to 20 of their co-workers to get information, then it's a really bad way for them to be able to collaborate, because of the fact that you've got now 20 different copies of the spreadsheet. You've got to try and put it all back together again. And there's just a lot of problems with, you know, utilizing those sorts of tools. So one of the things that many departments do is they'll buy commercial off-the-shelf software, and you know, they'll buy all sorts of disparate programs trying to you know, solve the problems for themselves, often without looking at what other departments are doing or what IT has available. They'll just go out and buy something that they think will help out meet their priorities. And then next we have departments developing their own apps. So they start building applications for themselves, often using contractors or IT-savvy business users. And the end result is that the departments start forming a mini IT within their own department. So they have, you know, they're starting to do their own development and hopefully maintenance and so forth within their own department, rather than relying on a central IT department. So there's a number of benefits for a department, I should say, with creating shadow IT. First one is that departments know their own requirements the best. So there's no disconnect between those developing the apps and those using the apps. Because of the fact that they're building them for themselves, then they know what they need better than anybody else. The apps are generally developed much faster than waiting for IT, because of the fact that they're setting their own priorities. They're not placed on a very long laundry list of requests, and so they can prioritize those applications which are most important to themselves. The other key thing here is that these are apps special or designed specifically for that department, rather than having to compromise. So often if they're using enterprise apps, then it may not be a good fit for what they want to do within their department. And so by building it themselves, they can get exactly what they want. And they can also improve the business practices, because of the fact that they're replacing things like Excel or paper with applications. So it's better than the position they were at before, when they had no shadow IT at all. And then lastly here, they have their own budgets. So because of the fact they're not spending their money on things like ops and enterprise apps and all the other things that IT need to concentrate on, they can actually just budget money they need for building their own applications. However, there's also a number of issues with shadow IT. Lack of security. So one of the single biggest problems with applications developed in this manner is that they haven't gone through proper security, or sorry, I should say generally haven't gone through proper security reviews. There's an increasing risk of data breaches and loss, or of data corruption. It's unsupported. So if it's built by contractors or interns, as soon as they finish that application, then they move off and go and do other work. IT often can't assist them, because of the fact it may be built in a technology that IT aren't familiar with. And often these applications are great once they're first delivered, but there's nobody there to actually maintain them or enhance them going forward. So if there's any changes required, then it's often very difficult to update some of these applications that are built within shadow IT. There's also rarely adherence to any of the standards or best practices that are generally followed within IT. So there's often poor database design or incomplete applications, inconsistent user interface or user experience, etc., across these applications. one of the other big issues within with applications developed by Shadow IT is it's often duplication of effort. So multiple departments building very similar applications. So you end up with 5 versions of customers, and it's not apparent who has the master record for that particular customer and the information that should be stored for that customer across the organization. And then there's also very poor integration. So it's very difficult to get data into many of these applications, or indeed to get data out of them that may be required for other applications, either within the department or within other departments, or within an IT system, for example. So let's now look at one of the best ways to resolve many of these issues that I've just gone through, which is looking at low-code development. So at a simplistic level, low code is all about doing declarative point and click 4GL type development versus writing copious amounts of code, or 3GL type code. This definition here from the Forrester Wave, I think very much sums up a good way to think about low code, which is platforms that enable rapid delivery of business applications with a minimum of hand coding and minimal upfront investment in setup, training, and deployment. So it's all about using declarative development, doing some coding, but making sure that we deliver very fast results with high quality. So if we have a look at productivity versus control, and we first of all look at no code, then if you are actually not entering in any code, then it's a very productive way to build applications. However, you can only generally perform the functions that are provided within that platform. So the next step down is to actually look at low code. And low code is where you've got the high productivity with a much greater ability to customize, but rather than writing lines and lines of code, much of it is declarative, so you've still got a high productivity, but more control than you do with no code. And then if we move down to full control, then you can build almost anything because of the fact that you're writing in something like Java or JavaScript, etc. And so you've got a lot of control in what you build, but therefore you're sacrificing productivity to be able to build those applications. One of the things to note is some low-code tools transition very nicely into full control. Other tools can fall off a cliff, so to speak, and require a lot of hand coding as soon as you step outside of their primary capabilities. So let's look at a few examples of what I mean by no code, low code, and full control. So no code is all about things like wizards, being able to use drag and drop, fully declarative. So the users are not expected to enter in any code at all. They're simply clicking around and selecting the components that they want to build the applications. Low code is where you start to introduce entering in code snippets. You can call out to database programs, utilize plugins, and so on. And then with full control, we're getting into procedural coding, integrating APIs, utilizing third-party libraries. So you've got, you can basically, as I said before, build whatever it is you need for your application. So now let's look at why you should use low-code frameworks. First one is low barrier to entry. So low-code frameworks should be easy to learn, so they're not overly complex. You should be able to quickly convert concepts into working applications, and it's easy to obtain an environment to start developing your applications. It should also be easy to deploy those applications. It should involve less coding. So the less lines of code you write, then the quicker and cheaper it is to develop your applications. But also, very importantly, it's a lot cheaper and easier to maintain and enhance those applications going forward. You get high productivity because of the drag and drop capabilities, pre-built feature functions, and the simplicity of deployment. Then it should be very quick and easy to build an application, and as necessary, iterate that application and deploy it over and over again until you've met your customer requirements. So I think one of the most important aspects of low-code frameworks is it allows those developing the applications to concentrate on business requirements. Because of the frameworks providing the underlying infrastructure such as security, data access, and so forth, developers can concentrate on meeting the business requirements rather than low-level coding to do things like session state management. And then it's all about releasing apps faster with the least amount of work. So rather than developing in weeks or months, rather than developing in months or years, you're developing in days or weeks. And generally, with most low-code frameworks, you're doing it with a small team, not a huge team that's working for extensive months. So you're not investing a lot for these applications. And one of the key things with that is, if it doesn't pan out that the application's truly as valuable as the business thought it would be, then you haven't spent 6 months and a lot of money developing that application. So to basically put it on the shelf is not such a big loss for the company. You can move on and build another application and better meet their requirements. So the next thing to look at is who should use low code to build applications. And the first one is IT professionals. So often when people think about low code, they think about citizen developers, and it's primarily aimed at citizen developers. I, on the other hand, think it's really that low codes are most powerful in the hands of IT professionals. Why? Because of the fact they know how to build applications, they know how to build data structures, they know how to take requirements and convert them into working applications better than citizen developers generally do. And so if you combine the skills of an IT professional with a low-code platform, then you get very high productivity. You can very quickly build proof of concepts, and given that they're IT professionals, they can also extend the applications using things like JavaScript, HTML, and CSS as required. The next group is DBAs and DevOps. So way back when I started, then DBAs used to build many applications for themselves using things like Oracle Forms because of the fact that they were SQL and PL SQL based. Then with the Java languages and .NET coming in, then it really moved out of the scope of most DBAs to be able to build applications for themselves. However, with these low-code platforms, then DBAs and DevOps people can and are building applications for themselves. So they have many requirements which are not enterprise applications, but applications to help them run the data centers better, to help manage the databases and the backups and what have you. Then that's a very good use case for low-code platforms. The next one is the departmental developers, those in shadow IT, so that they can actually standardize their internal development practices. They can use tooling approved and managed by IT, and they can utilize components developed by IT or other departments within their applications. And then lastly, we have citizen developers. So a citizen developer is not every user in the organization. It's those that are IT savvy, those that are used to building, say, Excel macros or an Access database, for example. So they have some experience with, data manipulation, and they should be able to readily learn how to utilize the low-code platform and build applications, especially as they know their own requirements better than anyone else. So the outcome for that is IT is more nimble and responsive because of the fact they can develop applications very quickly, and they can start meeting some of the backlog of applications that they have for the different departments. Departments start using a common platform rather than each department building applications using, whatever tool of flavor it happens to be for that particular point, or, the language that the contractor or intern happens to know. There's also an increased pool of development resources because of the fact that now everybody's starting to develop with the same low-code platform. Then you're getting more expertise across the organization. And very importantly, it's fostering collaboration rather than confrontation. So one of the biggest problems that IT faces is how they work with shadow IT, because basically at the moment within most organizations, it's either ignored or it's frowned upon, and there's very little efforts to actually try and work with the different departments and get value out of the resources that they have within the departments and start utilizing them in a way that's good for the organization. And so by using low code, you can get a win-win-win. So IT has stopped fighting with the shadow IT, and they can actually start getting value from working with the different departments. The departments get better applications and more secure applications. And the organization is more efficient. So they're not spending as much money because there's not as much duplicated effort. And, the IT resources are being used more efficiently. So the end result is that apps will be built faster, of higher quality, and better meet requirements. Now let's look at Oracle Apex. So Apex is a high productivity development framework to easily build modern applications using Oracle SQL. If we have a look at this diagram here, you'll see that there's a lot of different ways that we can design the database. From, for IT professionals that can actually write full-blown SQL to things like Quick SQL where you're entering in shorthand. And so there's flexibility there for everybody from citizen developers to be able to use something like Quick SQL to the IT professionals to be able to build, complete data structures. When it comes to actually developing the applications, we provide a number of different capabilities and very importantly, we make it very easy to iteratively develop your application until you meet the requirements that you need, and then easily deploy that application to production. Oracle Apex provides a lot of no-code capabilities. We also allow you to enter in code snippets and what have you right throughout the application definitions. And then as needed, you can incorporate JavaScript, extensive SQL and PL SQL, HTML, CSS, and what have you. But importantly, when you start adding in that code, you don't have to write hundreds of lines of code. You can just write small amounts of code to meet your specific requirements in most cases. So it provides you with the creative freedom with the least amount of code and the least complexity to be able to build your applications. So some of those capabilities, powerful wizards. So you can build many different components either with the Create Application Wizard, Create Page Wizard, within Page Designer. You can use the declarative metadata to actually be able to readily create your applications, but just as importantly, you can easily enhance and maintain those applications going forward. And it's not just the developer who originally created that application, but any developer should be able to easily look at an application and be able to see what's being developed already and be able to enhance it as required to meet new requirements. The built-in processes for CRUD operations. So with majority of Apex applications, you're building it on top of Oracle database objects to be able to query up a table, be able to insert, update, delete, etc. Then that's all, click, and you're done. You don't need to be writing code to be able to do that in most cases. And then we've also got the pre-built controls for things like security, data typing, validation, session state management, and more. So that, as I said earlier, developers are concentrating on business requirements rather than low-level coding for, determining authentication and authorization and so forth. And then lastly, as needed, you can readily enter in SQL, PL/SQL, and other snippets to meet your requirements. We're also very flexible in building your applications rather than needing to worry about whether this is a desktop or a mobile or running on a tablet. Instead, as a developer, you just build the application and let the actual framework take care of the responsiveness and making it accessible, etc., for your end users. So how do you actually go about implementing a low-code framework or platform? First of all, you need to prepare the environment. So create a hosted environment that's open to all, and preferably open to all departments, all employees, not just those in IT. The wider you can make your audience, then the more chance that you will have people coming to you and actually starting to utilize this platform to better build these applications and support the organization. A key factor is to actually build internal expertise within IT so that you can help support the applications that are being built. Also provide links to learning resources. So when it comes to things like Oracle Apex, there's things like Apex World and the Slack channel, there's the discussion forum, there's a number of videos out there, there's a lot of information on apex.oracle.com, and you need to actually collect these together and actually make sure that people coming in to start learning the environment know where to get these resources to get started and to help them as they're moving through developing applications. And part of that is of the preparation is also to define how you're actually going to support these application development efforts. So that may be a help desk, it may be a mailing list, it may be just a discussion forum, etc. It may be that you have people going out to different departments at different times. The next thing to concern yourself with is partnering with Shadow IT. And one of the best ways to do that is to actually provide an IT mentor that can work with these different mini IT departments to actually start getting them on board with utilizing the low-code platform. Identify apps that are low-hanging fruit. So initially you don't want to try and take on large applications that they built internally within the departments or ones that are highly complex. You want to try and pick off some simple applications so that the departmental developers can start getting their feet wet with simpler applications that they can get some quick wins on and start get familiar with, rather than trying to start at the biggest applications that are required. It's also advisable to actually jointly develop the first applications, or at least a proof of concept, so that the departmental developers actually feel that they're being supported rather than just being given a new tool and saying, go build. And then, very importantly, one of the key ways that you can get the Shadow IT departments to actually work with you is to start providing them access to corporate assets. So, corporate data for the customers or the orders, etc., that would be very valuable within their applications that previously they may have had a lot of difficulty with getting that information. By making that easy for them to actually utilize, then they will start wanting to come to your platform. Provide tips on how to get, so the next thing to do is to try and actually connect with citizen developers. So provide tips on how to get started. Because of the fact that they're often not IT professionals, then you'll need to give them a bit more assistance on getting up and running. Instruct them on how to solve simple use cases. So this can be as simple as some videos on how to convert a spreadsheet, or how to start building your first application. one of the key things that we find when you start working with citizen developers is often they don't know how to properly model relational design. And so teaching them, for example, how to use QuickSQL and how to embed different tables so you get master details as required is very important. And also teaching them about good development practices and the importance of things like security and to consider security at the beginning of your application, not at the end of the application. And then also providing access to IT professionals on a scheduled basis. So that might be once a month that you have a drop-in area, or that they can phone up, but providing them with some additional support of people that they can call on when they get stuck. So now I'd like to turn it over to questions and answers. And Tim, if you can ask the first questions, please.
There have been some relative questions regarding how you deal with the difference between doing development that is web-based versus the client-based structure,
Sure.
and how you deal with that in this environment. Could you speak to that?
So Oracle Apex is purely browser-based. So as a consequence, you're working from your browser. So, you know, when it comes to being able to interact directly with your underlying desktop, for example, then that's not part of what a browser is designed to do, because of the fact it's a browser. So when it comes to interacting with things like Word and Excel and things like that, then you need to look at different wrappers that might be available to do that. There is, you know, the browser capabilities are being extended, but one of the things to understand is that to build intuitive, well-performing web applications, then you know you need to try and break away from some of the old ways of doing things, like you know, I want to be able to edit Excel directly within my application. Well, wouldn't it be better to actually move that data from Excel up into a database table and actually be able to maintain that data in a single source of truth, and then only if really necessary actually download that data back to Excel, for example. So, you know, when it comes to things like on your phone and trying to access the camera and things like that, then there are utilities like PhoneGap which allow you to interact with those and provide APIs to be able to talk or communicate with other aspects of your device.
Regarding the conundrum here, do you have any customers or examples of customers that have been able to do this successfully or fostered this type of environment?
Yes. One of my best examples is a airline actually in Europe, where they did a top-down approach rather than a grassroots movement up, where they only have 6 certified development tools, and they actually set up a central IT supported workspaces where anybody was allowed to go and sign in. They were the ones that actually set up a monthly call-in so that developers, and when I say developers, I'm talking about anyone from departmental developers, from citizen developers, IT professionals even, can actually go to the experts once a month and have them look specifically at their application. So, you know, it's one thing to get some advice on, you know, how do I, you know, create this sort of widget, but it's something else again for an IT professional who's very experienced with the tool to be able to come in and say, okay, here's my application, here's what I'm trying to do, and have the IT professional actually work with them on their application to help to try and implement that specific functionality. You know, they had a lot of internal resources and standards on, you know, how to design the database components, how to actually develop your applications, how to check for security. So, using some of the built-in capabilities that are within Apex of going through the advisor was one of the things that they included. But if you're a new developer, you don't even know about that capability, so wouldn't know to even go on and check on it. I know that there's a lot of organizations out there that are struggling with how to work and get the best value from the different departments out there. Departments are frustrated because of the fact they're not getting support from IT. IT are frustrated because departments aren't working, following their standards and what have you. And utilizing a tool such as Oracle Apex is one way to really try and get cohesion between these opposing forces and start working towards a common good, so to speak, for and ending up with much better results as a consequence. So with that, I'd like to thank everyone for attending, and make sure you have a good rest of your day.